Professor George Becky leads an interdisciplinary robotics research program at the University of Southern California, which is trying to get machines to learn from the world around them, like humans do, and explore how robots interact in ways that mimic groups of animals.
Colonies of robots have some of the same kind of advantages that groups of humans have as compared to a single human. One is redundancy. So one human can be sick and the project doesn't stop. The same, of course, is true of robots. If a robot develops the flu, then the other robots can take over.
Are you using compasses for anything?
No, not at the moment. It's still all the old code.
One of Dr. Becky's colleagues at USC specializes in the interaction of groups of robots.
What we're looking at is generating natural and lifelike behavior in our robots. And what we're in particular interested in is what simple rules inside the robots can result in complex and useful and lifelike repeatable behavior. What we're really trying to demonstrate, what our theory is that it's not so much what's inside each of the agents and what's in their heads, but what emerges out of their interactions.
The interaction of multiple machines to discuss among themselves how they ought to allocate a task, elect a leader if a leader is needed, and perform the task without human assistance. Those things are definitely going to happen.
Robots are also learning to do new tasks without human assistance. An industrial robot can move through a series of pre-programmed movements, but learning to interact with the environment is much harder.
Look, it has a puck.
Can have machines which learn by looking or by watching someone, and we can have machines which then could use these behaviors and refine them over time and even develop new behaviors. So they could all of a sudden come up with something which you had not expected before.
Bouncing a ball by a robot is a way of attempting to understand the way in which complex coordinated movements are done by humans. If we understood the way this kind of coordination takes place and how rapidly it takes place, not only would it help us to build better machines, but it would help us resolve issues in which those systems are damaged in ourselves. So I think one really needs a long view in things like this.
Recent research has shown that there are important emotional factors in human decision-making. At MIT's Media Lab, Professor Rosalind Picard is researching ways of introducing emotions into computers to make them more intelligent.
What we're advocating is a computer that uses emotional mechanisms in a very subtle way that you may not even see on the surface. It may simply make decisions that seem more intelligent because it actually has these mechanisms. They adapt better to us. If you're getting irritated or frustrated at something the computer's doing, it would have the ability to recognize that and change its behavior in response to you. What the computer should do is the same as what a skilled human would do in that situation. So if a skilled human would try to put the fearful user at ease, then maybe the computer should try to put the fearful user at ease.
Kevin Warwick thinks our only hope for controlling our future intelligent machines is to become them.
If you can't beat it, join it.
To figure out how we might join our brains with machines, Kevin's lab is conducting an unusual experiment. Taking live brain cells from a rat and embedding electrodes in them.
And when we've got about 100,000 of these neurons linking, communicating together, we're connecting it up to a robot body.
That's right. Kevin Warwick is using the living brain tissue of a rat to drive a robot.
That brain is the sole controller for the robot body. We don't have a computer in there that's doing some little things and changing the signals.
Sensors on the robot can detect the walls, and through a wireless connection, it sends that information to the sliver of rat brain. The brain then actually tells it to turn left or right to avoid the wall.
And the output from the brain, which we can pick up as electrical signals on different electrodes, drives the wheels of the robot.
To let the rat brain know when it's successful, Kevin stimulates it with a little extra voltage as a reward. Brain cells like being stimulated.
It's a bit like giving a child an ice cream, but you can't be sure the child's going to do exactly what you want it to do, and the same is true with the biological brain.
Kevin Warwick isn't just creating a brain-controlled robot for fun. He sees it as a necessary first step toward the eventual merger between man and machine.
I would be able to give myself all sorts of abilities that I don't have now. Extra memory, new means of communicating, getting different sensory input instead of being limited to the 5 human senses. Your television set can sense the world in infrared. You can't. Surely you must feel a bit jealous of that. I certainly do. I want an infrared sense. Why not?
His goal is nothing less than to be the one who ushers in a new age of fully cyborg humans.
That new cyborg with a part biological and part machine brain is what will go ahead and dominate the world in the future.